The waiting times at a surgery are thought to be normally distributed with a mean of 5 minutes and a standard deviation of 2 minutes. So we're saying that the time is normal 5 and 2 squared. Find the probability a patient waits less than 4 minutes. So we're after the probability of t being less than 4. So we're just going to go to the calculator and normal CDF, and the lower here, although you can't really have this as a time, I'm going to put in negative infinity, and for the upper I'm going to put in 4, and the standard deviation here is 2 and the mean is 5, and so that's 0.3085. Correct to 4 decimal places. We now want to find the probability that 20 of the patients in the waiting room, of 20 patients in the waiting room, exactly 3 wait less than 4 minutes. Well, the first one says using the exact distribution. Well, this looks to me very much like a binomial. There's 20 patients in the waiting room, and the probability of a patient waiting less than 4 minutes is 0.3085. So the probability of x being equal to 3, because we're after exactly 3, is going to be, so I'm going to go and find my binomial PDF app. We want x to be exactly 3, given 20 trials and a probability of success of 0.3085, and that is 0.063, correct to 3 decimal places. Now we want to do that using a normal approximation. So my normal approximation, so we need the mean for this distribution, and that's just going to be 20 times 0.3085, so 6.17, and then for the variance we need to multiply that by 1 take away 0.3085. So 4.27, let's call that. And then using the continuity correction, we would want y to be from 2.5 to 3.5. So I'm going to go and find the app, and I'm going 2.5 to 3.5. Sigma would be the square root of 4.27, and mu 6.17, and that is 0.060 if we give it to 3 decimal places. So it's actually not a bad approximation at all.